Hi, I'm Hongshuo Wang. Today I'm going to present the Retrieval Enhanced Open Relation Modeling. In daily life, you are trying to reason between two unknown entities. You may search through Google, or you may go through the dictionary to look up the definition of each entity. You may ask some people, like a professor or your friend, to see whether they can give you some explanation. Pre-trained language model contains a wealth of knowledge, can possibly give out the relation between entities. What is open relation modeling? Open relation model is given to entity, let's say head and tail. Our goal is to teach pre-trained language model to generate a coherent sentence to describe these two entities. Even though pre-trained language model have already learned a significant amount of knowledge from rich text corpora, to refresh or expand their knowledge, we have to retrain the entire model, which is painful and takes lots of time and computing power. Instead of seeking knowledge through our memory, can we search through external knowledge? Retrieval augmented model address this issue. It gives you the access not only look up your trained knowledge, but also look up external knowledge, such as a few pieces wiki passage. Retrieved enhanced open relation modeling is an open relation model that combined with non-parametric memory by jointly learn knowledge from retrieved accessible knowledge base. By the way, the external knowledge we are using here is millions of wiki passage whose index are assigned with a unique dense representation that we can possibly retrieve by some encoder in an efficient way. When we get the basic idea and intuition behind our model, the results things become much clearer. Since the original open relation model trained on the wiki dumps, in order to compare it with baseline, we need another new benchmark to avoid data leakage. Otherwise, the ground truth may exist in the retrieval passage. The table in the slide lists all the websites where the data collect from. All these websites are domain-specific encyclopedia, which not only provide informative context, but also provide a significant entity. In the example, each website will have a corresponding entity and its related context. I divide the 6 different websites into 3 corpora, which are science, biomedicine, and philosophy. I displayed 2 plots to show the number of sentences and the unique entity from each website. After we get the raw data, the question comes to how can we extract the ground truth, the relation description between two entities? Here, I propose a self-supervised learning method to automatically extract the relation description by utilizing dependency parsing and entity linking. Briefly speaking, first, we preprocess the data and utilize the POS tagging combined with depending parsing to get the most frequent depending tag patterns. Then, we utilize some heuristic rule to control the sentence format. All the requirement has already listed in the slide and can be satisfied by utilizing spaCy library. For example, let's say we want to satisfy the independence. The relation of the target entity is described independently and not based on its context. We collect a common transitional expression, like conjunctive adverb, to form a dictionary to filter the sentence, and only keep the conjunctive adverb, which shows the relationship in the space and time. The intuition behind it is in academic writing. Also, usually use transitional expression to connect one idea to another between paragraphs or blocks of the text. For detail, please see my final report. After running a self-supervised learning method pipeline, what we get are several sentences. and each of them describe a relation between two linkable entities, such as wiki title or encyclopedia title in some specific domain. However, it's still not enough to form a benchmark. We need each of our sentence to be informatic, precise, and correct to describe the two significant entity. In order to ensure the quality of the benchmark, I manually labeled the rest of the sentence and form a compact dataset with about 10K sentences. The criteria are displayed in the slide. The final dataset is shown here. I only pick the sentence whose score above 3 to form my dataset. And for the testing and validation set, I only pick the perfect sentence with the highest score, which is 5. Most of label entities are wiki titles and can be found in the corpus. After finalizing the dataset, we need to implement our model. My original idea is to leverage reg model, which described in the well-known paper, Retrieval Augmented Generation for Knowledge-Intense NLP Task, written by Dr. Patrick Lewis. However, during the implementation, I found out that the retrieve wiki passage actually introduced the more unrelevant information, and the processing speed is extremely slow. That forced me to look up some SOTA model to deal with this issue. My solution is to adopt the fusion encoder model to generate relation description and use the dense phrase to retrieve related sentence. FID, also called the fusion encoder method, are first described in the paper Leverage Passage Retrieval with Generative Model for OpenQA. Briefly speaking, this model uses cross-self-attention to process input passage jointly instead of concatenated together like RIG. This model outperforms RIG model on OpenQA task. Utilizing dense phrase is another trick to improve final performance. This model first introduced in the paper Learning Dense Representation of the Phrases at Scale, written by Dr. Danjing Chen. Briefly speaking, they adopt a similar architecture as the retriever in RIG. However, instead of retrieving the passage, they are focusing on more fine-grained level and retrieve the phrase span with only 20 tokens. Like I showed in the slide, dense phrase retrieve is super fast and almost 30 times faster than the retriever in RIG. Based on my experiment, dense phrase has better performance on zero-shot definition generation. At last, here's my pipeline. Give two entities as the input. We first generate 3 prompts. For example, what's the definition of the entity? What is the relation between two entities? Then, we send this prompt to a dense phrase retriever. The model will return 3 times k in total relevant passage, where k is the number of retrieved documents. At last, we combine two entities with pages together, then feed them into a FID decoder. Due to the limited amount of time and computation resources, the retrieval result shows in the table. As you can see, our model performs slightly better than baseline model. There are a few directions to improve my model that I plan to try in the future. I list all of them on this slide. At last, to conclude there, in this paper, I propose a new retrieval enhance the open relation modeling. Give two entities a model which combine pre-trained parametric and non-parametric memory for the relation description generation. Second, I collect a new benchmark to evaluate the performance of a retrieval enhanced open relation model on various corpus. At last, I declare a self-supervised learning method to extract relation description with dependency parsing and entity linking. Thank you for watching.